Okay, today we are going to start lesson 16.2, which is graphing inequalities in two variables. So what that means is we are going to graph on a coordinate plane the solutions of a linear inequality in two variables. When it says two variables, what that means is x and y. Then we're also going to be able to interpret the graph of the solutions of a linear inequality in two variables. So what we're going to do is we're going to use the slope and the y-intercept in order to graph a line. We also need to determine whether to graph a solid or a dotted line and plug in a test point to determine where to shade. We're also going to be able to determine and explain whether an ordered pair is a solution or not. So if you were to open your book right now, you would see an example A and example B, and they're already solved for you. The book graphs it, does everything for you. And then after that, they give you 4 problems to work through, but they don't actually give you the graphs or the space to graph on. And the My Notes section of the book is not the best option. So I have kind of taken the book example and I've added a few extra notes to it as well. So we are going to fill in some of this together. So a solution to a linear inequality is all of the ordered pairs that make the inequality true. It's like the shaded region that we looked at yesterday in the book. So we need to determine which ordered pairs are solutions to the linear inequality below. So if this is my x and this is my y, I'm going to take this x value and substitute it in, and take this y value and also substitute it in. So what that means is we're going to see if this is a true statement or a false statement. If we plug it in and it's true, it means it's a solution and it's in our shaded region. If it's false, it's not a solution and it's outside of our shaded region. So I'm going to start with a 2. Then the x is going to come out, and I'm substituting in the 2, minus 3. I'm no longer going to have a y. We're going to substitute in the 5. So we can do this in our head or type it into our calculator. 2 times 2 is 4, minus 15. 4 minus 15 is a negative 11. Is negative 11 less than 15? Is negative 11 smaller than 15? This is a true statement, so yes, this would be a solution. 2, 5 is a solution to the linear inequality. Okay, so let's do the same thing for the next ordered pair. Again, we want to plug in negative 1 for x and negative 7 for y and see what we get. So 2 times x, which is negative 1 this time, minus 3 times negative 7 is less than 15. So this is negative 2 plus 21. It's less than 15. And we that 19 is less than 15. Is that true or false? This is a false statement. So that means that I'm going to say no. -1, -7 is not a solution, so it would not be in our shaded region. Okay, try the next one. Two times 3 is 6. -3 times -4 is 12. 18 is less than 15. This is a false statement. So again, no, 3, -4 is not in my solution region. It's not an answer. And let's plug in 0, 0. So 2 times 0 minus 3 times 0. Well, anything times 0 is 0, so this is 0 minus 0, which is just 0. Is 0 less than 15? So this would be true. So I could say yes, 0, 0 is in my solution region. So out of these four, which one was the fastest or the easiest point to plug in to test? Definitely 0, 0, right? Because anything times 0 is 0. So we are going to use this 0, 0 moving forward as a test point. So we're gonna use this further down on your worksheet. Okay, let's get into the graphing. Graphing linear inequalities is a way to show all the ordered pairs that are solutions. So let's look at our steps to graph. So step 1 says put the inequality in slope-intercept form. And I only have to do this if necessary. If y is already isolated or solved for, I'm good. If not, if it's in standard form, I need to convert it to slope-intercept form. So it might look like this, y, and then over here we have mx plus b, and our symbol could be less than, greater than, less than or equal to, whatever it is. As a reminder, just like solving inequalities from first trimester, we need to make sure that we flip our inequality symbol if we're multiplying or dividing by a negative number. So if I multiply or divide by a negative y, I need to flip my sign, or by a -2, or by a -3. Step 2, we need to graph the line. So first, let's plot our y-intercept on our y-axis, our b value. And then we're going to use our slope, our m, our rise over run, to plot multiple points. And don't forget, a positive slope increases, a negative slope decreases. We are going to use a solid line for less than or equal to, greater than or equal to. We use a dotted line or a dashed line for less than or greater than. And step 3, we need to figure out where to shade, where that shaded solution region is. So we need to choose a test point that's not on the boundary line. And like we saw above, the easiest point to plug in is 0, 0. But if my graph goes through 0, 0, if my line goes through 0, 0, I have to choose something else to test. So above we could choose 2, 5. We could choose -1, -7. We could choose 1, 1, 2, 2, 3, 10. It does not matter as long as it's not on the boundary line. If the result is a true statement, we are going to shade the half or the portion of the graph that includes the point. And if the result is a false statement, we are going to shade the opposite way, away from that point, because it's not a solution, it's not in our shaded region. So let's walk through graphing this example, which is from above. So step 1 says put the inequality in slope-intercept form if necessary. Currently, this is in standard form. AX plus BY is less than C. So we need to convert this to standard form by solving for y, or isolating the y. So what would our first step be here? We need to subtract 2x. Subtract 2x. So these cancel, and we're left with -3y is less than, I'm going to write -2x first, then plus my 15. Divide everything by a -3. And we should be saying alert, alert. If we divide by a negative, my inequality symbol has to flip and go the other direction. These cancel. 2 negatives give me a positive 2/3 slope. And 15 divided by -3 is -5. And now we can graph this. So I've put the inequality in slope-intercept form. I flipped my inequality symbol because I divided by a -3. Now I need to graph it. So let's plot our y-intercept down at -5. 1, 2, 3, 4, 5. And my slope is positive, so I want my line increasing. So I'm going to go up 2 over 3. And if I go up 2 over 3, I'm going to be off my graph again. So run out of space. And if I look at my symbol, is this going to be a solid or a dotted line? It's going to be dotted. So I'm going to use my ruler and connect these, but it's going to be dotted or dashed. Okay, so now I need to decide, am I going to shade above this line in this big, huge area, or am I going to shade below the line in the teeny triangle? Well, we already did the work for this above by plugging in all of those test points. Okay, so above, we plugged in 2, 5, and it was a true statement. So over 2 up to 5 was a solution. And when we plugged in 0, 0, we also got a true statement, which is a solution. So we need to shade towards these 2 points. But let me show you plugging in 0, 0 again as well. You can plug in 0, 0 to this original up top and say 2 times 0 is 0, minus 3 times 0 is 0. So 0 minus 0 is 0 is less than 15. That's a true statement. Or we could also plug in 0, 0 down here to this new slope-intercept form that I plugged in. So 0 is greater than 2/3 times 0 minus 5. Well, that's 0 is greater than -5. Is 0 greater than -5? Yes, this is also a true statement. So either way, we're shading towards that 0, 0, or towards that 2, 5, however you want to think about it. So I'm going to shade this entire area and that is my solution, my answer. Now, remember above we did 3, -4, and that was not a solution. So notice it's in my white area. It's not in my common shaded region. So it's not a solution. Okay. All right, let's look at question 1. Y is greater than 1/3 x minus 5. This is already slope-intercept form. Perfect. So let's go ahead and start graphing this right away. Remember that -5 is our y-intercept on our y-axis. So go down 1, 2, 3, 4, 5. Plot your point. My slope is a positive 1/3, so up 1, right 3. Up 1, right 3. Up 1, right 3. Down 1, left 3. Down 1, left 3. Down 1, left 3. And if I'm looking at my symbol, this is a dotted or a dashed line. So I'm going to make dashes here. And the easiest test point to choose is 0, 0. 0, 0 is right here. So 0, 0, this is x and y. So think about substituting in 0 for x and 0 for y. So if I write that out, it's 0 is greater than 1/3 times 0 minus 5. Well, anything times 0 is just 0, so this is gone. 0 is greater than -5. 0 is greater than -5. Is that a true statement or a false statement? This is a true statement. So what that means is 0, 0 is a solution or is an answer, and it's in our shaded area. Okay, so we are going to shade towards 0, 0 and everything above our line. So shade above your 0, 0. Question 2. This is already in slope-intercept form as well. So my y-intercept is 0, -1. So we're going to plot that point on your y-axis. Your slope is -2/1, and this is a negative, so your line needs to be decreasing. So down 2/1, down 2/1. And then go the other direction, up 2/1, up 2/1, up 2/1. And this is going to be a solid or a dotted line? Solid. Okay, so use a ruler, please and thank you, and connect your line. And the easiest point to choose to plug in is 0, 0 for both x and y. So this 0 goes in here as its replacement or substitute, and this 0 goes in here for y as its substitute. So if I write it out, 0 less than or equal to -2 times 0 minus 1. Well, anything times 0 is just 0, so these cancel, and I'm left with -1. Is 0 less than -1? False. So because this is a false statement, think 0, 0 is right here. I need to shade away from that, the opposite direction. So I'm going to shade like down and to the left of my line, if that makes sense. So away from that 0, 0 point. So we're shading this path or this portion of your graph. Okay, hopefully you can keep going.